Today we're going to talk a little bit more about these word problems with systems. Word problems with systems are very challenging. It's very difficult to sometimes see the equations that you need to come out of the words first, let alone being able to then use our methods. But we're going to try to walk through a couple of examples here, and again, doing the best we can to try to pick through word problems to see how we can create some equations. So first of all, what you definitely want to do is define the variables that you want to use. So what you want to do at some place in your work area is say x's will equal bananas, y's will equal apples, just so that when you get to the ending answers of x's and y's, you know what they represent. It's just a way to kind of get in your head and write them down someplace. Then, this is the tricky part. Find the information that is in common to build two equations. Not easy. It's not always that one information set is in one sentence and the next information set's in a different sentence. Sometimes it is, but not always. But it's important to try to come up with some common things to help build two equations. So things in common are big. So sometimes pictures, drawings, some kind of a verbal model might help. And again, it really comes down to your personal preferences on how this works. So then the step 3, you're using one of the 3 methods we've been talking about. Sometimes you might decide graphing, substitution, or elimination to solve. And then you always want to make sure that you're answering the question that's being asked. Answer the question and include your labels. You can't just say my answer is 3, 2. Because in word problems, what does 3 mean? What does 2 mean? You can't just put 3 and 2. You have to explain with the labels. So let's just do a couple of examples. So the first one. There are a total of 64 students in a drama and yearbook club. The drama club has 10 more students than the yearbook club. So first what we want to do is let's define what we think are going to be our 2 labels. We're going to use x and y. So I'm going to say that the drama club is going to be represented by x. The yearbook club students will be represented by y. So that's kind of just me just defining those 2 things. Next, we want to talk about some common things. So what I notice here is I have a total of 64 students in drama and yearbook. So I believe that would be something that could maybe create an equation. So then the second equation is comparing. Drama club has 10 more students than yearbook club. So I think we can create 2 equations from that. So the first one, total. Hopefully we're good with total means addition. Right? We total up things. So basically my first equation is going to be x plus y, a total of drama club and yearbook is 64. So there's one equation right there. The second equation is a little bit trickier. So we basically have the drama club represented by x, has 10 more students than the yearbook club. So there's 2 ways that I could do this. I'm going to try to show how we would build. So one of the problems that we might run into here is lots of times we think 10 more means 10 plus. And a lot of times we'll say x plus 10. But if you think about it, x, which is the drama number, is the bigger number. Okay? So if I think about it, the drama club has 10 more than the yearbook club. It really would be the yearbook needs the plus 10 to come up to the level of the drama club numbers. Now you could have done subtract 10 from drama club to bring it down to the yearbook club. This one's a tricky one. It takes practice getting good at it. But think about it that way. The drama club, let's say, has 24 students. Well, hopefully you would be good with saying that that means the yearbook club has 14 because it's 10 less or than the other one. But this would be how that equation might work. So now they want to know how many students are in the drama club, how many students are in the yearbook club. So this is where our system comes in. Now looking at these two, I would say that the graphing method wouldn't be terrible, except this first one, I got to go way up on the scale here. Okay, the elimination one could use possibly, but to me this is a perfect substitution one, right? We want to be good at all three of them. So I'm going to use the substitution method. So remember, in the substitution method, we need one of the variables solved in one of the equations. This one is solved for x. So because it is solved for x, so let me just write this again. I'm going to take the expression that x's are equal, and I'm going to plug it in to the other equation where I see x. Notice that we're plugging in x this time. And then those two, when I merge that together, the second equation is now going to look like y plus 10 instead of x plus y equals 64. So remember, I should see all one variable in my equation, which I do. I only see y's. So that means we can carry on. So then I would say y plus y is 2y plus 10 equals 64. I would subtract 10 from both sides to get 2y equals 54. And then when I divide by 2, y equals 27. And now remember, we need the x and the y. So this is where we can decide. I'm going to plug the y equals 27 into one of the equations. And this one I don't really think is a big difference. I'm going to pick the second one. So we'll go with this one. I'm going to plug in y as the 27 that we found from the first equation. So x equals 37. So then the question comes back to solve the equation with labels. So this basically tells me, try to pick a color we haven't used, I really can't. So my final answer is x represented our drama club. And y's represented the yearbook club. So there is our final answer. We have 37 students in the drama club, 27 yearbook students. If you add those two together, 37 and 27, you get 64 like our first equation. 37 is 10 more than the yearbook club, so there would be our answer for that one. All right, so on the next one. Now we're trying to sell lemonade for $2 per cup and orange juice for $3 per cup. You sell a total of 100 cups for $240. This is an example. This one's even trickier than the first one because you have information from both in both equations. So I can't just say the first sentence is one equation and the second sentence is a second equation. So this one's tricky. So let's just first do our kind of defining things. So we want to look at our our lemonade. We'll call our lemonade X, and we'll call the orange juice Y. Okay? So you sell a total of 100 cups. So we're going to do just kind of like we did a minute ago with our drama club and yearbook students. We're going to use that first little piece right there, a total of 100 cups, to be our first equation. Because the second part of our second equation is dealing with money. But this one is kind of tucked into that second sentence. But basically, I have some number of lemonade, cups-wise, plus some number of cups of orange juice. And when I total them together, we get 100 cups. So then the second part is going to be combining the two sentences now. So we're selling lemonade for $2 per cup and orange juice for $3 per cup. So we're talking about money. And then this one is saying a total of 240. So in this one, I'm going to be saying that I'm going to sell $2 times X number of lemonade cups plus $3 times Y number of orange juice cups, and the total amount of money is 240. I know it's tricky, it takes practice. The more you do them, it comes a little bit easier as you go. So then, here we are. We could do graphing, we could do substitution, we could do elimination. So here, I could definitely work this one to y equals, or x equals maybe, to definitely get a reasonable substitution. But to me, this one is built perfectly for the elimination method. So let's look at the elimination method. So elimination method, if you recall, says you need opposite coefficients for one of your variables. Okay, opposite meaning that the number in front of the x's, that's their coefficients, has to be a 2 and a negative 2 maybe. The number in front of the y's would have to be a 3 and a negative 3. So I'm just going to go with, both of those would be not too bad to do, but I'm going to focus on the first one, just to try to keep our numbers smaller. And I'm also going to focus on the x's changing. So I need the x coefficient to become a negative 2. So remember when we did our elimination, we're going to multiply everything in that entire equation, both left side and right side, by whatever number we pick to multiply. So we're going to multiply by negative 2. So what that's going to change this into is negative 2x minus 2y, so it's like a distributive property, and then minus 200. And don't forget that right side as well. So now we've changed the first equation. Now I can bring over the second equation that we're going to match it up with, and we're going to then use addition. So we have these opposite coefficients right here. So now I can add these two up. Negative 2x plus 2x becomes 0, or eliminates. Negative 2y plus 3y equals y. Negative 200 plus 240 is 40. That worked out easily. I didn't have to do much more besides that. So then we need to know, well, what is the x? So again, if the y is 40, I can go back into one of my two original ones. I'll pick the first one, again, because it seems easier, less stuff to do. If I plug in the y as a 40, and now I'm solving for x. I get x equals 60. And then again, like we've been saying, I can't just say x is 60 and y is 40. So we got to go back and answer the question. So how many cups of lemonade did you sell? Well, lemonade was our x's. So we first want to say we sold 60 cups of lemonade. And then y was our orange juice amount of cups. And we sold 40 cups of OJ. And then again, to check this, we would do 60 plus 40. Yep, that equals 100. If I plug in a 60 here times 2, I get 120. If I plug in a 40 here multiplied by 3, I get 120. 120 plus 120 is 240. That tells me I have the right answer. So again, word problems with systems are very tricky. They definitely take time to get good with it. Look for things that are in common to try to create your two equations. Then you can use whatever method you want to use, but we do want to be smart in looking at our methods. and thinking about what would be easier, substitution or elimination, or possibly graphing. So hopefully this works. If you have any kind of questions, please feel free to ask. We'll be working on these for a little bit, and we'll see you in class this week.